Why, hello. I didn't see you there. Welcome to Chef Baker's Cooking with Chemists, where today we'll be demonstrating some interesting topics in chemistry through cooking s'mores brownies. These are the ingredients we'll be using. The interesting topics in chemistry that we'll be demonstrating are phase change, as performed by Chef David, heat transfer by me, Chef Baker, the Maillard reaction by Chef Sally, and lastly, specific heat by Chef Maddy.
Hi, I'm Chef Sally, and now we'll be making the brownie mix.
Now I'm going to talk about phase change. A phase change is when a substance goes from one state of being to another without a chemical reaction. Melting is a type of phase change. To melt, a substance has to be heated to its melting point. Melting point is the amount of heat energy needed to break the intermolecular forces in a substance. While the phase change is going on, the temperature of the substance will remain constant.
Specific heat is the amount of energy in joules needed to raise 1 gram of a substance 1 degree Celsius. Specific heat is important in cooking because it affects how long an object takes to heat up and therefore how long it takes to burn, denaturalize, etc. The intermolecular attraction forces and bonds in a material determine the amount of energy needed to raise the temperature of an object. The stronger the intermolecular forces, the more energy is required to break the attractions between particles, and therefore the higher the object's specific heat. Some bonds, such as hydrogen bonds, have the ability to absorb more energy before they break. This is the reason water has such a high specific heat, 4.1 joules per gram degree Celsius. We used an aluminum pan, which is ideal when making brownies because it has a high specific heat. Therefore, it'll take longer to heat up the brownies, and therefore we can leave the brownies in longer without them burning. We also use aluminum foil when making the crust because the aluminum foil also has a high specific heat.
Welcome back. The chemistry concept I'll be demonstrating today is heat transfer. There are 3 types of heat transfer: conduction, radiation, and convection. Conduction, by a scientific definition, is the transfer of heat energy through direct contact of molecules. So the molecules of one hot substance are in direct contact, or they're touching that of another substance, and the heat is transferred from the hotter one to the less hot one. In our example of melting chocolate sauce, the hot iron skillet heated by the stove is transferring heat through conduction. The pot is touching the iron skillet, so the molecules of the pot are in direct contact with the molecules of the stove, and that's heating through conduction. The second type of heat transfer, radiation, is the transfer of heat through electromagnetic waves which heat up the air or particles around it. In the example of the chocolate sauce, the fire generated from the stove rises and through electromagnetic waves heats the air around it and the pot, thus heating the pot and melting our chocolate sauce. The last method of heat transfer is through convection, which we use to bake our brownies. Convection is the heating of air, which rises and falls because hot air rises and cool air lowers. This creates a circulation of air within the oven, which is what cooks the brownies. These currents of waves pass through and around the brownies, making a heated environment around the brownie pan, allowing the brownies to leaven and cook, and that's how we made our brownies.
While making these awesome s'mores brownies, 2 different elements go through the Maillard reaction. These 2 elements include the brownies and the marshmallows. But today, in our cooking show, we will focus on just the marshmallows. The Maillard reaction is responsible for changing the texture, taste, and the color, as well as the aroma of food. It is a chemical reaction that requires proteins, sugars, and heat. 3 stages make up the Maillard reaction. First, a group of sugars reacts with an amino group on a protein or an amino acid to create water and glycosamine, a derivative of glucose. In the second stage, glycosamine goes through rearrangements to produce aminoketose compounds. Last, when these compounds go through many more rearrangements, molecules that contain flavor, aroma, and color are produced. This process describes why the marshmallows have a harder texture as well as the golden color. The fun fact of the day: the Maillard reaction can create harmful and cancerous chemicals that can create